Hi folks, Iron Geek here. Unfortunately, it looks like the microphone was turned off or the battery ran out at the beginning of this talk. But when you get to just a little bit before the 2-minute mark, audio will return. Sorry for the inconvenience.
No one started using it. We good? Okay, appreciate it. So, what we want to talk about is how you can use artificial intelligence in your threat landscape. One of the things we're going to discuss is the recurrent neural network. So, for anyone who is familiar with different AI terms and machine learning, there's various neural networks that can be set up. And Steve, you want to talk about what most people think of when they think of computing and setting up a network? Can't walk around.
I can't and escape. So, with regards to neural networks and machine learning, the whole idea is to basically mimic the synapses that occur in the human brain. So with neural networks, and especially in the ones that are being applied in the InfoSec space, it's a hierarchical type of system where basically you feed it information and it filters through the different nodes, just like a thought process would filter through the human brain into different synapses. So depending on how much resources you have, one of the key components around neural networking is computing power. So given the advent of AWS, Google Grid Computing, Microsoft Azure, you have the ability for companies nowadays, as opposed to standing up 5,000 CPU or 5,000 servers in racks like they used to back in 2000, early 2000s, you can instantly stand up a very, very large neural network up in AWS and be able to harness that computing power to be able to mimic larger and larger neural networks.
So one of the things that happens within the neural network, when you look at the bottoms-up view, in normal computing, you type in, you tell the computer what you want to do, like when we were all kids, and you want to see your name flash across the screen, and then you got the output that you wanted. In neural networks, what's actually happening, the neural network, when you give it a huge sample set, and then you tell it what you think the outcomes will be, and you help it learn how to compute where you want to go. And it's constantly talking back to itself. So there's the generational side of it, as well as the learning from point A to point B. But then you also have, in a layman's terms, from point A to point Z. And it'll know everything in between, and then what the mistakes were and how things move forward from that. So in the InfoSec space, everyone else has been making advances. A lot of us feel that we're kind of like the the guy right there just, clean up on aisle 4. There's a crypto variant that's attacked us. There's, this phishing campaign that's come after us. Everything that's happened. So everyone's waved a white flag, and we've bought more and more tools and brought them in instead of looking at ways to use various technologies that are out there in the market space to get away from just a tool aggregation throughout our system. So basically we've got a mop bucket there, and we've tried to make it go faster with more tools. Where we see this going is everything that we've had before, AV, HIPS, sandboxing, isolation, EDR, most of these things are human involved, right? You have to have someone writing signatures. You have to have someone writing the code. Where we see it going is where you're going to get to only AI is involved, where you do not have to have the people involved. The computer is going to be smart enough to make the decisions for you. With artificial intelligence, you can use the power of machine learning to unlock the DNA of advanced threats. Using those huge neural networks, huge sample sizes, you can figure out, is a file bad or is it good? You can train if something were to get through and say, this got through, how did it get through? So how does this happen, actually? So the big key is, one, the computing power that large neural networks like Amazon have allowed us to do, but the next biggest key is the sample set. Does anyone know, over the last 7 days on VirusTotal, how many executables have been submitted? Various pieces of malware, executables. Just in a 7-day running period. Just a random guess. What's that? 7 million? It's a good high number. It's 1.9. 1.9 million. Different pieces of malicious executables. That's just over a 7-day period. So the sample set that we now have available to us is extremely large. So the key is you're able to train those neural networks on these huge sample sets, whereas before that wasn't available to us. So Steve's going to talk a little bit about the extraction of that information from those large sample sets.
So as you feed, thank you. So as you feed the sample sets into the neural network, the idea is to actually train the neural network with knowing where to look initially. So that's basically what's called seed attributes. So starting with a neural network, you would normally start with a couple thousand, like 2,500 seed attributes that you would examine of the file as it sits on disk. Examples of those are the different. First off, let me show of hands. Anybody have done malware reversing? Oh, hey, Mike. A couple of people, right? So the idea behind features, and what is a feature or an attribute, is what are the different distinct components of an executable as it sits on disk. So executables, they have to follow some type of standard in order for it to be executed by the OS, correct? So this screenshot is from PE Studio. This is something that you would just use to examine a file to determine whether or not it's malicious from a static analysis perspective. If you notice here, it shows the PE header information. That's sort of like the table of contents in a book. The different sections that are contained within that executable that would represent chapters. The address allocations, page numbers, etc., including maybe string analysis, what's contained within the strings. So all these different types of things are attributes that you can glean from a file as it sits on disk. So during the initial process of telling the machine how to learn, you're basically telling it where to learn. And as Art mentioned earlier, AI is a generational type of approach. So where you might start with 2,500 seed attributes, eventually the artificial intelligence neural network will start to learn and start to extrapolate new features on its own, and that's how it's actually designed to do those generational leaps. So where, for example, you might start with 2,500 seed attributes, eventually you start hitting millions and tens of millions. of attributes that a machine learning neural network can glean from a file in order to make that determination of, is this bad or is this good?
A lot of times people will talk about the human brain and how it sort of mimics a neural network. When you think about a baby and how they learn and how they grow, if you give a baby a ping pong ball, right, you tell it to them, you tell them ball, and that's the only ball they've ever seen in their lives. They take it and they drop it and they see it bounce. And the very next day, you give that same baby an egg and you tell it ball. They're going to think it's a ball. They have no sample size, nothing. Now, you take all of us in this room, we could probably be blindfolded and handed hundreds of different balls, and just by feeling it, and we'd know tennis ball, baseball, basketball, whatever it might be. That's where that sample size and then the ability to compute the different kind of attributes of what you're feeling, what you're touching, works, if you can visualize it in a neural network. So when we get into how it works, because there is everything you can just see normally and that a reverser could see, there's first order features, second order features, and third order features. And this gets into that deep learning where in the one slide where it showed the connections back and forth with each other. So the third order can be talking to the first order, can be talking to the second order, and based on what's happening within those orders, it will derive information.
So this is where it gets a little fuzzy with regards to how to explain this, because when it comes to it's basically you start to enter mathematical concepts, right? So the third order features are derived from second and first order features. For example, you may have it's instead of it just looking for negative features, things that are indicating that it's bad, you may start to see combinations thereof combined with absence of good features that make up a whole new feature. And that's how we're able to grow from 2,500 attributes or features that the machine learning is examining to millions, because it's extrapolating and basically deriving more features from as it learns. So once you get to the third order feature level, you're basically starting talking about mathematical concepts such as detrended fluctuation analysis, mean change point modeling, and wavelet energy decomposition. Now, who here has never heard of those terms? Wait a minute, you have. No, the guy. So, you get a door prize, sir. So before starting at Silence, I had never heard a lot of these terms. And in reading some of the abstracts, I can't make it past the abstracts when it comes to a lot of the white papers that's been produced by our data scientists around how this actually fits into our AI approach. But suffice to say, it's one of those things where being able to apply these advanced mathematical concepts to attributes and deriving more features is a way to get more granularity and more ability to determine whether or not something's malicious or good. So here's some examples, right? Obfuscation of the executable. So how are malware authors generating so much malware out there? Well, if I'm a malware author, right, I stand up my infrastructure, my command and control infrastructure, and then I create my payloads, executables, have a way to deliver those payloads. But the crucial piece that I need to, manipulate is the payload itself. So what's an easy way to manipulate a payload to basically reset everybody to day zero when it comes to examining what's bad or identifying what's bad? One way is to use packers. A packer is just basically a smart compression utility that tears apart the executable, going back to the sections of the executable that we were talking about earlier. It may add some obfuscation techniques, such as compression or encryption in certain areas. That would represent first order obfuscation. Meta obfuscation techniques would be like inserting dead code into those different sections, and then that way, when you put it back together, it's fundamentally changing how that actually looks to any type of system that's actually examining the files, right? So the contribution of AI in that space is using, something like structural and temperature entropy analysis, which actually looks at the different obfuscation techniques and meta-obfuscation techniques and starts to draw conclusions based upon the data that it finds. So, for example, detection of packing, basically looking for patterns of entropy change. So as you pack a file, you're starting to introduce entropy into the inside of that file. And then, for example, here, this is actually derived from one of our data scientists' white papers. They're able to derive 387 different mathematical features from those types of meta-obfuscation techniques.
The big key within AI is just because something is being packed or trying to show itself does not mean that it's malicious, right? So you have to train on that set in order to make sure that it understands what is bad and what is good. Because there's plenty of reasons for people to use traditional packers, right? So you can't have AI just triggering or any other tool on anything it sees as packed, making it bad.
So just go back and recap the process of this. This represents the process of training. I'm sorry, go ahead. Well, the first order features are the features of the program. The second and third order features could be derived from, what you just mentioned. I would say both, right? I mean,
so they train the model constantly, right? So as the sample size grows, they're constantly training the model, and the model itself is becoming smaller. We're on the fourth generation math model particularly, and it's actually smaller than the first one.
So just to recap on the AI process here: collection, which is massing all these different millions of samples. Extraction of the features, and then next is transforming those features into something numerical that can actually be used, right? So the transformation is basically just assigning numbers to the features that are found. Now, how is that actually used? Well, it's used to derive different matrices that are used for clustering and classification of those features in relation to each other. So what happens is you start to see different features based upon the calculations and those plotting of the numbers start to actually kind of cluster together. That portion of the AI is basically derived. It derives a algorithm that is used by whatever tool that you're going to use to analyze the files. So, in a nutshell, all this process that we have here is done during development, right? It's the development of the product, it's the development of the solution, and then it is distilled into an algorithm that is input onto the agent. So the agent basically contains this output of the machine learning, which is the algorithm, and that it's used to actually determine what's bad and good. So what does that mean? In practice, it means you look at the agent or solution can then look at the attributes of a file as it sits on disk, assign numerical values to the attributes that it finds, and then plugs those numbers into that algorithm, which is the output of the artificial intelligence that's actually produced during development. So it reduces the work from, as opposed to different approaches where you would actually compare lists. It actually reduces it to a mathematical process. So as you plug those numbers into the algorithm returns a score, and then you make a determination of whether it's bad or good based upon the output of that algorithm. Yes, sir.
Sure. The accuracy level current with the fourth generation math model is 99.8%. The false positive rate is 0.0002%. And it's very interesting, not to get too much in, but we'll have like what someone would consider a false positive. We had one where the guy's like, false positive, here it is. He goes, this was a piece of vendor code. It's an update signed by the vendor. And so on the backside, I asked our people, like, why do we trigger on that? And they said, well, because it's malware. And I said, I'm going to need a little better answer than that, take back to the customer. And they said, we'll get on the phone with them and WebEx it and show them the command and control structure. Here's what it's doing. Here's where it's going. It went through all of their trust models, right? So they got it from the vendor. It was signed by the vendor. It went through their various trust model. They passed it out. So they took it back to the vendor and said, what's going on? The vendor was like, yeah, we just realized that we were owned. And we've been delivering malicious content out. So the 15 million attributes, when our CEO, Stuart McClure, the original author of Hacking Exposed, he talks all the time about you can't try to beat the 15 million attributes. That's a non-starter, right? What people are going to be trying to do is get creds on your network, right? That's still what they're trying to do. But from beating the engine, it's just highly unlikely at this point. Then the last picture here is kind of another diagram of that very simple one at the beginning, where depending on the output, right, that starts, you can see all of the various connections that could potentially possibly happen all the way front to back. And that's basically, if you think of every line in there as an attribute, that's what you're seeing.
Not only that, but this represents only a 30-node neural network. So you can imagine the connections if you start to deal with 10,000-node neural networks, right? So depending on how many features that you're extrapolating and the groups of features that you're extrapolating and how much computing power that you can actually put to this, the amount of connections between the different layers of the neural network start to grow incredibly. So with that, we're going to show it working?
Yep.
All right. So Macs don't like SVGA, right? Especially VMware Fusion within it. Go ahead.
So currently we're on the 4th edition, and it's getting updated about every 6 months from the initial time that the product came out. But it is static. We have people using this product from the very first edition in industrial control systems where they've completely air-gapped the network and never touched it, and they just leave it alone. Let it run. You can take the original math models, and it's always kind of neat when a new piece of malware comes out, Locky, whatever GlassRat, whatever might come out, and run it against the old math models to watch its effectiveness. So you're looking at a math model from 18 months ago to a piece of malware that everyone's having problems with today. So it's kind of cool to watch those things happen.
Okay, cool. All right, so a little bit about the environment here. MacBook Pro dedicated to this. I'm connected to my MiFi. So if you see danger live malware, don't connect to it. It'd be bad. So I have two machines that I have here. One has a inspect upon write to disk. That's the dark green one. And then the light green one is actually highlighting execution control. So before it's going to do the examination before it's allowed to execute. Both of these are completely disconnected from the network. So it's in offline mode, meaning there's no connection out to the internet. There's no reliance on some type of callback. I do this to isolate the agent so we can actually examine the agent's functionality by itself. So the first thing we're going to do, do it over here too. Okay. So we're going to take the sample set, drag it over here, and we might drag some others as well. So let's see, Tesla Crypt 3. Now, a little bit about this. These represent, and I'm going to drag them also over here, because we're going to try to execute them over here. So, if we go in here, thank you, sir. All right. These represent malware that I downloaded this morning, and I used a packer to create mutations of them. So basically, these are repacked. They were pulled down from a public repository. So basically, starting with something that everybody knew about, and I used the same technique that malware authors use, would repack these. Basically, if we take a look at these, if you notice, the names of them are the SHA-256. So taking this one, send to MD5 hash. The name contains, the original 256, SHA-256. This is the packed SHA-256 version. So all these are just basically new pieces of malware. So we're going to open the command process here. Check that. And so, just to reiterate, this is relying on the output of the artificial intelligence neural network. These haven't been seen before by the system. There's no, update that was actually pushed out or nothing like that. And it's going to, before execution, pause the execution, extract those features that we were talking about, assign numerical values to them, plug them into the algorithm, and then return a score. Based upon the score, it's going to find them good or bad, right? So we're seeing access denied from the command line, because basically Windows is trying to execute these, and as it's trying to execute them, the agent's actually pausing that execution, and you see basically things have been quarantined based upon just that algorithmic examination of the file attributes. Any questions about that? So if we go back over here, now if you notice, some of these, well, that was fast. There's mutations that were there. I wonder if there's any still there. All right, so this is not cooperating. I wonder. This is actually what it's supposed to do. Go ahead. Completely.
We download them all from VirusTotal. All right. Make sure that 20 of the various vendors on VirusTotal said they were malware. Then we pack them using VMpress.
Correct.
Right.
So, yeah, great question. I'll get back to this. So we have some good files here that are packed, right? I'm going to drag those over. So these are sysinternal tools. I've used vmprotect to pack these. So to basically, I don't know if you can see this, but the size is completely different, right? So basically a new version of Procmon. So as I click on this, it's allowing it to run because it's looking past the fact that it's packed and looking at the underlying attributes and determining that it is good. So that's the same system, same policy. It's just, in this case, file was good, and it was allowed to run. So, getting back to what I was saying about this piece here. This was set to examine files as they were written to disk. It quarantined them a little fast for what I was going to point out, but let's say something happens and even though it's set to examine upon write to disk, you get in here and before you're actually able to examine, you actually try to click on it, right? So these haven't been quarantined yet because they're queued and it takes a little bit of time. But when I try to execute them, it's still moving it back. It's moving it to the top of the priority at that point and relying on execution control. So there's a couple mechanisms. One, watching for new files, run the algorithm. If that doesn't do it fast enough and someone tries to execute it, there's a backstop of execution control. So before it's allowed to execute, it's able to do the analysis. Now, which one?
Got a faulty VGA cable up here. There we go.
Okay, don't touch it. All right. I'm going to go ahead and accept the EULA on my Adobe Reader just because I hate for it to pop up and get into my way. Oh, no wonder. So I'm using Adobe Reader 9 something, which, how vulnerable is that, right? All right. Due to screen resolution issues, I'm going to have to unplug it so I can accept my EULA here. Okay. Okay, good. And I'm going to do the same thing on the Windows Microsoft Office, so that doesn't gripe at me either. Don't have an activated version of Office. Okay. Yeah. Okay. Now, I'm going to go ahead and load up this the task manager here. We're going to take a look at the process while it's doing this. So, the PDF is actually a weaponized PDF. And what's going to happen when I click this is because the PDF file extension is associated with Acro Reader, we'll see Acro Reader launch over here. And then the PDF Acro Reader will start to read in content. When it hits the portion of the content that contains an exploit, we'll see the agent step in, block it, and actually terminate it, right? So there's our Acro Reader. It's trying to read the content. And when it hits the portion of the content that contains the exploit, in this case it was a stack pivot, the agent detected that and said, no, let's shut that down. Now on the Windows doc format, right? What happens a lot of times when you have malicious doc? They embed scripts or scripting attacks within a macro. This one has a little bit of social engineering. Says basically, hey, content's locked for security. Please enable the macros to view the content. So as I enable this, it's going to try to launch a script. And we'll see it pop up and kind of go away because the agent's able to detect that it's an unauthorized script, and that's bad.
So any questions? Yep, there we go.
Unauthorized script. You don't sign it. It's based upon a different type of exclusions that you would do. typically there's a learning process. Basically, yeah. Correct. Correct. Correct.
So we see that at Silence that artificial intelligence is going to have a ton of uses in InfoSec, from eventually passwords, credentials, network uses, and because of the power of the sample size that we now have and the power of the computing power that's there for us, we think it's going to make leaps and bounds for everyone in the InfoSec community on stopping kind of malicious actors throughout the world. That's Stuart's goal.
Yeah, we're starting to see AI used on the network space as well. There's actually one vendor out there as well.
Dark Traces out there.
Oh, couple different vendors that are actually using AI on the network space as well. So I'd be interested, as a security geek, I would be interested in see AI start to be applied in the SIM space maybe, or in credentials management space. There's a lot of power that can be leveraged across InfoSec, not just for malware. So us being one of the first, hopefully we start to see it in other portions of the community.
Yep. Yeah, so we are a Microsoft AV. If you go out on Microsoft's website, we're a Microsoft approved AV. So you can definitely remove us from that side of it. We have PCI and HIPAA, various certifications from various attestations. So. Yeah.
So that's what I meant by attestation.
It doesn't matter what QSA you get, right? You could have QSA A. We worked at a consultancy that had multiple QSAs that couldn't agree on anything, right? And so you'd have one go into a customer and he'd say they have to do it this way. You have another one come in and say they couldn't do it this way. But we've had multiple QSAs approve us as an AV and approve us to replace the current AVs.
As the control, not a compensation.
Yeah. Yeah, the attestations from those various consultancies. You can. None. Like you put in some exceptions in your current AV, and that allow us to run. At first, when we first came out 2 years ago, no one even cared, and then now there's been some problems where they'll try to kill us as a process when we're out there. So put in an exception to make sure that we can run, and it goes from there. Windows 10 for any as an OS, when any AV hooks into it, it sets off Defender. But we've now, because we're working with Microsoft, we've gotten around that where we can basically trigger a flag that doesn't register us as an AV, so you can have both Defender and us as well. Any other questions? Yep.
The first round and the second round?
The first round and like half of the second round of funding, which is close to $50 million. Stuart will talk about the very first check went to pay a rent check to Amazon.
The AWS still is.
Yeah. So.
Yeah, so even though I'm disconnected, the policy is downloaded. It will, if it's connected, it gets the policy, it gets everything that it needs to know, right, to run locally. If you have a disconnected network, like an ICS environment, like SCADA systems or whatever, that's completely air-gapped, we have a disconnected mode where you can actually bundle the policy with the executable, sneaker net it into your segregation, and it can run completely autonomous. The cloud connection is really only required for event management and policy pushes down. Great question. I don't know. I think it may be a little bit of both. No, I don't think it's a secret. I think I just don't know.
That's for someone to ask.
Yeah. What? I'm sorry. Yeah. So it's a very, very lightweight overhead. If you look at like the process here, it's usually around between 40 and 50 normally. This one is run a little hot right now, but if I go to the other one,
Just drop down.
oh, did it?
Yeah.
Yeah, that one's around 30. It's usually around 30 to 50 meg. Even when I'm running malware against it, I never really see it hop above too high above 100 meg, even with throwing 100 pieces of malware at it.
Yeah, although not supported, people are throwing out Raspberry Pis. So
Yeah, that's about 28.
it's extremely lightweight. Yeah.
But there are platform support, requirements. If you have a specific need for custom hardware for it to run on that, we've done that for other companies through basically co-development efforts. For example, we can't say what aircraft company or what vendor it was, but it was basically porting it to a Linux-based system that is inside aircraft for the communications for the passengers. So that was a tailor-made type of development effort. Right. Again, if it's one of the supported platforms and systems, including embedded systems, then it's no issue. If it's something unique, possibly we could do it if there's enough money involved. I didn't want to be so crass as to say, well, it depends on how big your checkbook is. But yeah, it depends on how big your checkbook is.
There is a lot of, depending on the type of SCADA system, a lot of the power, electric that's already moved that way, some nuclear, and different things that have very specific systems. There's various medical places that are looking at and have put it just on their medical devices. So
the Internet of Things is going to be really interesting space for this because it is so lightweight. That's all I'll go.
We can spin up POCs pretty easy. So that's just if you're talking like home use, no. But if you want to just spin it up and take a look at it, it doesn't take any more than a 30-minute call with Steve. And
away
we go.
Back to what the gentleman was saying as far as the cloud management, all the management is 100% software as a service. So there's no management infrastructure that you have to worry about. We're going over.
All right. We appreciate it. Thanks, everybody.